Hi, I'm Dr. Nijisha Shachal, Assistant Professor from Department of Biomedical Engineering, SRM Institute of Science and Technology, Katanglathur. We are seeing Unit 1, X-ray Imaging and Digital Radiography from the course Principles of Medical Imaging. In this unit, we are going to cover the last topics of this unit, that is dental X-ray machine, portable and mobile X-ray units, digital radiography, flat panel detectors. Let's start the session. Dental X-ray machines. So these are machines which are used to detect, to take the images of the teeth, the internal part of the teeth, how the degree of the decay, how they are arranged, everything can be imaged with the help of dental X-rays. So this is the only tool which can be used to image clearly the teeth and the bone, the jaw structure, everything can be imaged using the dental X-ray machine. Now, the only challenge, if you see here, is the X-ray machine, no, whatever you're going to design for dental X-ray, it has a small area. The reason is that the teeth, the jaw, everything is in it is in a small region. So your X-ray tube and the detector also, the distance between the X-ray tube detector, it's going to be very, very short. In that case, what happens is that the X-ray machine that you're going to apply for dental X-rays are going to be of low power. So that is more than enough to apply a low power X-ray to take the images of your teeth. So the most dental units, they have a fixed tube voltage of around 50 kilovolts. So it is very, very minimum 50 kilovolt with a tube current of 7 milliamperes. So we have actually seen the filament current of around amperes, but here for dental X-rays, it is all in milliampere system. This also has a high voltage transformer because we're talking about in kilovolt. But the thing is, everything becomes very compact. If you see the high voltage transformer or the high frequency transformer along with the X-ray tube, everything comes in a single case. So you just have the X-rays to be just delivered and you have the film. That's all. Everything is very, very simplified, and there are the positioning, everything is very, very compact in case of dental X-ray machines. So this is how a dental X-ray machine looks like. You can see here the X-ray and the output tube, everything you can imagine, and this is the X-ray of the dental system. Now for dental X-ray, it has a special result. We saw that we have a cathode, we have an anode. So cathode is going to give you the electrons, and anode is where the electrons are going to go and collide. Now in between both, you have a third electrode called as a grid. Why is this grid placed in between both of them? The reason is that when the cathode releases the electron, actually the electrons, they gradually increase. So at first second, at first second, what happens is you have the electrons to be producing 1, 2, 3, like that. It becomes thousands and 10,000 millions like that. So what happens is gradual electrons, this when it goes and again collides, X-rays that is generated also, it becomes gradually, it increases. To avoid all this, what we do is we use a grid electrode which will catch all the electrons and it will wait, and then it will throw everything together at the to the anode. So what happens, in a very small duration, in a very short duration, you have a whatever required amount of X-rays to be produced. So this is what is being discussed here. So it contains fewer useless soft X-rays and more hard X-rays. So what happens because of that? It is more effective and it can be compared mathematically to a much higher output, resulting in a short exposure time. Next, let us see about portable and mobile X-ray units. So these are conditions. There are conditions where you cannot move the patient to the X-ray rooms. Okay, so the patient cannot be moved, and in that only way is to move the X-ray unit to the patient. So in that case, we can have three options. One is with the help of portable units. Second is mobile units, which are more bulkier, and then you have mammographic X-ray equipment. These are also a smaller version of the actual X-ray machine. Let us see one by one. So portable units are nothing but it can be dismantled, you can pack it into small cases and you can move it. Wherever you're going, you can take it, go fix it and you can do it. So in this case, what do they do is the high voltage generator as well as the X-ray tube. Everything is enclosed in a single system. So you have a single block in that everything is done. Whatever X-rays that are generated, you carry that with the help of an arm to the area that you want to image. So that will be a separate section, this will be a separate section. So the anode, everything will be in a single unit. Also, to reduce the energy of the X-rays, everything will be lesser when compared to the actual X-rays. You cannot expect much clarity, but whatever is required can be immediately diagnosed. So hence what this is say is we use a stationary type of anode because you want to reduce the the supply voltage, everything has to be reduced. We are going to use a single main. So you are going to use a domestic supply to power it. So we use everything of a low ampere. So you can see here it is around 15 milliampere, and the range of its maximum that it can go is to 20 milliampere with 90 to 95 kilovolt supply only. The tube head, now you have the tube where it is going to fall and take the output. Everything is, you have a separate system, and that's a cross arm which is in the vertical column. So wherever you are going, you can carry that, connect both of them and take the image. The second type is the mobile X-rays. So these are nothing but where in case of mobile, meaning that you can move them. So you can carry the control table and the column which is supporting the X-ray tube, which are permanently mounted on the mobile base. So in this case, the patient table, the X-ray tube, everything is connected together. Okay. So they are usually heavier when compared to portable units, and they are capable of providing higher outputs. Because you have the table, the film and the X-ray tube, everything is fixed together. They give more better output images. The mobile units, they provide a greater selection of milliampere and kilovolt ranges. So that in case of portable, you are going to dismantle and take it. Here it is more bulkier version, and but it can move it. If you see here, it is of current is little bit higher, 300 milliampere, and the amount of voltage that you need to supply is 125 kilovolt. So this type of output, you need to have a main power supply, but it means that the power supply must be more higher when compared to the normal domestic power supply. Now, in order to get a consistent output, no, from one power supply socket, you use calibration, you adjust everything, and you have a particular setup to ensure that the whatever power that you require for the unit is being given. Now, whenever you have limitations in the electrical supply, you can use battery powered circuits also to power it. So this is an example of your portable and your mobile X-rays. So you have the whole system. So these are all examples of both. So usually interchangeably they use both of them. So these are some examples. You can see everything is in a single unit, the generator, the X-ray thing. Then this is the vertical column. Wherever you want, you can move it and you can image it. So this is the portable one. Okay, I told you very, very small. So this is how, in which stage it is going, the advancement. Okay, they made it very, very compact, battery powered and all. The last one in portable is that the mammographic X-ray equipment. These are more compact when compared to the actual X-ray machine. Now, mammography, it is used to examine the female breast, and it is mainly used for the diagnosis of breast cancer, or if you have any, if you want to go for needle biopsies, you want to guide the needle correctly. At that time also, we go for mammography, which is using X-rays. Now, if you see here, the breast, there is no bone, which means that you're going to use very, very low intensity, low energy X-rays. So hence the radiation dose that you're going to give it has to be very, very low as possible. But it has to also give you the spatial distribution. I need to know what is inside. So spatially also I must be able to take, as well as I must not create ionization or create cancer for the subject. So X-ray tube, if you see, it has small focal spot size, and they minimize the possibility of geometric blur. So if you send the X-rays fully, you will not get the proper resolution. So what you do is you have the focal size to be as minimum as possible. Now if you see here, usually we have molybdenum type of target X-ray tubes with beryllium window and of 0.03 mm molybdenum filter. So it's all very, very tiny and small. Okay. So usually the kilovolt that we give is very less, as well, same as almost similar to that of dental, which is around 28 to 35 kilovolt. Now, if you see what are the components, it has an image acquisition, display and storage. Everything is done independently, allowing for optimization process. So this is an example. So what they do is they keep the breast in between, they press it so that you reduce the area of the breast, and then you give the x-ray, you send the x-rays and you take the cassette. So inside you will have the imaging section, and this is how the x-ray tube. So this is also very compact tube. So inside this system itself you will have the generator, everything. Okay, so the top you will have the, so here you can see the tube head, everything, the compression device, the cassette holder, all that. Now to the last section of this unit, which is your digital radiography. So if you, what do you mean by digital radiography? Whatever that you're talking about, you're going to digitize it, see it in a computer. So this allows image processing for a better displayed images. You can, what you can do is you can use lower dosage, improve the image with the help of image processing algorithm. So this becomes more easier and more efficient way of diagnosis. So you can even store it in a digital way. You can transfer it. So you can go for remote image viewing, teleradiology, all can be done. So this digitally formatted images, it will permit digital storage, retrieval, transfer, display. Everything is possible with the help of digital radiography. In case of digital X-ray imaging system, we need two parts. The actual imaging, correct? You have the transducer and the data collection, all that. And the second part, which is the you're digitizing it and you're displaying it. So the digitally compatible X-ray imaging transducers, you can divide it into two categories. How do you digitize this? With the help of an image intensified TV system or with the help of a radiographic systems. So let us see one by one. In this, if you see angiography, this is the most common thing. So it is a very common term now. So to understand if there is any block in the circulatory systems, no, in that case we go for angiography. So it is a therapeutic modality which is concerned with the disease of the circulatory system. How do you do that? In this case, to view the vessels, actually when you try to use x-rays to image the vessel, it is not possible. You cannot image it because vessels, they are similar to that of the tissues. So what you're going to do, you're going to increase its density so that it reacts well with the x-ray by giving a contrast agent. So you're going to give a contrast material to opacify the vascular structure. What are the materials usually used is iodine. So iodine is a very, very common contrast agent. So you inject them and you wait for the iodine to pass through. Then you use X-ray and you try to image it. Since the vessels are having iodine, at that time it becomes highly dense and it will show that particular output can be seen in the X-ray. So you can see it in real time as a video, or you can even image it and you can take it in view. The most important application of digital technology is in the digital subtraction angiography. So what do you mean by digital subtraction angiography? We already saw angiography where you send a dye and you're going to take the image. You have something called as digital subtraction angiography. In that case, what you do is you take the image first before you give the contrast agent, and you take another image after giving the contrast agent. Then you subtract both of them. What happens in that case? All similarly existing areas will get removed and only your vessels will be seen. So this helps you to view properly to image the vessels. So this gives you an increased contrast. So you can see here, this before you would have taken an image, this with the contrast, you subtract both of them. This is the image with only the vessels with the contrast agents. This is the concept of digital subtraction angiography. Now, storage of digital images, it is required for both online and archival purposes. Online storage, it is provided by real-time digital disk. Then you have archival means they are mostly made by storage of hard copy films generated from the digital image. So like in long ago, like previously, in older generations, it was usually like they had only films. Okay, you didn't have a digital version. Now it is opposite. You have the digital version. Whenever you want, you can print it into a film. So this is how now currently the X-ray, the digital radiography is going on. Now hard copies in case of cameras, laser or video thermal printers anyway can be used. Now also it can be used as cassettes and optical discs can be used to record the angiographic procedure and associated images. So now they give it as a CD. If it is angiography, you can see the whole video from first to the last, or it can be only the images. Everything is possible. In case of we talking about digital radiography, this printing it and all, we usually go for phosphorus screen, which is used as a detector for digital radiography. The reason is that in real time, I have to detect it and I need to save it into, that is, I need to digitize it and save it into the computer. Nowadays, we use a more complex one, which is nothing but the flat panel detectors, which are used for digital radiography. So this is how it exists. So you have the X-rays. The X-rays, like we saw previously, you have the grid, and it will cross a grid, and it will come to the detector. Now, in the detector area, previously it was directly whatever is the, what to say, the phosphorus film, all that. Now you have something called as a scintillation concept, meaning that you're going to convert the X-rays into visible photons, that is X-ray into visible photons, and that visible photons are going to be converted into electrons. And once you convert the electrons, you're going to detect them. Okay, so this, how do you detect them? So this visible photons you're converting, right? The visible photon is going to be allowed to fall on a photodiode. Photodiode, what does it do? A photodiode will convert the whatever is the light photons into electrons. It will give you as an image, and this images from each and every part of your what to say, the panel will be detected and it will be imaged. So you can see here, you have, it has been divided into multiple pixels, and you're going to take it from each and every point. You're going to record it, you're going to amplify it, you're going to multiplex it, you're going to convert the analog into digital signals, and then you're going to view it into the system. So each and every pixel will be a photodiode, so perfectly will be able to see the image. So this is again the electronics in here. So this is the detector array. Inside the detector array, you have multiple elements, and inside the multiple elements, you have the light sensitive area, the detector element, everything will be seen. So pixel wise, you will be able to see the image. So it is usually made up of amorphous silicon, and they use etching. No, they call it as etching to get the necessary conditions for the X-ray detector operations. So this is the TFT arrays. It is divided into small detector arrays. They are called as flexels, and then the excels are arranged in rows and columns. So each and every what to say Excel will have a photodiode. It will have an electronic. Everything will be included inside a TFT array, a Dexel unit. You have a switch, the gate, source, drain, everything will be done, and they'll be connected together to get the output. So with this, we are completing this unit. Thank you.